It's recording. It's recording.
All right, so I'm Abigail Kimbrough. My pronouns are they, them. I was advised by Dr. Elizabeth Geary. Her pronouns are she, her. My presentation is on teaching gravitational potential energy, student interaction with surface manipulatives. Before we begin, I want to thank the whole PER group for assisting me in my thesis, as well as this presentation. So, an outline. What am I going to talk about in this presentation? I'm going to give you a little bit of background. What is the surface I used? What did I do in my presentation? And then, or what did I do in my thesis? Apologies. And then I'll talk about the interactions. How and why do students interact with the surface? And then I will conclude with why should you use this surface? So, let me grab my surface. This is the surface that I had students use in the activity. This surface represents gravitational potential energy of an Earth object system. And so a couple of things I want to point out about this surface. There are 3 marked points. You might be able to see them a little bit better on the screen. You have a blue circle, a green square, and a red or maybe orange star. And those are for teachers as well as students to use in instructional activities. There is an etched marking that I have highlighted here that represents the surface of the Earth. And then if you hold the surface up like this, the profile of the surface is what the graph should look like when you draw it, of potential energy versus distance. All right, so before I talk about what I did, I want to talk about why I did it. So various studies have shown that students have difficulty with some key aspects of gravitational potential energy and potential energy in general. 3 of those being students struggle with the fact that potential energy can be negative, relating the derivative of potential energy to the force, and then relating the signs between those. The magnitude should be equal while the sign should be opposite. Students often think that the sign should be the same. And then treating all potential energy as MGH. That's a very common thing because you first learn gravitational potential energy as MGH, and then later you learn that that's just an approximation for near Earth. So I used the activity that I designed to confront those issues and then gather data about possible ways that those issues could be resolved. However, this is just introductory data, so I will not be resolving those difficulties. So, in my research, I wanted to know how do students interact with this plastic surface that represents potential energy. I designed an instructional activity for students to do during a 50-minute recitation, and this was Physics 212 students. I filmed 3 groups of those students and then transcribed and analyzed the videos. So, as I was designing the activity, these were the instructional goals that I wanted to cover. I wanted to talk about the gravitational potential energy, and I wanted students to know that it increases to 0, meaning that while it does increase and while the height does get larger, it's actually negative the entire time. That potential energy is dependent only on radius, as you can see in this, where typically we hold m and little m constant. And then I also asked students to draw this graph without this equation. They were only given the surface and a contour map. Force, I wanted them to know similar things, that it increases to 0, and that force points opposite of the direction vector. So while direction points outward from the center of the Earth, force points inward. And then I wanted them to look at the relationship between those things, so that the slope of gravitational potential energy is the magnitude of the force. This is because potential energy is only dependent on the radius, so the gradient turns into a simple du dr. And then, like I said before, with the difficulties that students have, while the derivative of potential energy is positive, the force is negative. So, while students did this activity, they interacted with the surface in 6 key ways. I'll talk about 3 on this slide and 3 on the next slide. There was holding the surface, students picking up and otherwise moving the surface, students drawing on the surface, and pointing at the surface. We have gesturing at the surface, and I want to talk about this one a little bit. This student is actually using a pen here to depict the tangent to the surface at this point. the last group that I filmed was actually the only group to notice that you can place a pen on the surface and find a derivative, and if that derivative is only in the radial direction, that is the negative force. And then the last category is contour map. This is the contour map that the students were provided. I have not added nor deleted anything from that. And the contour map category was simply the students interacting with it in any way. Tracing was self-explanatory, students tracing things on the contour, or on the surface. So, how did students interact with the surface? One second. All right, I'm going to point out a few key things here. One of those being that most of these interactions are non-contact interactions. So tracing, while sometimes students do touch the surface while they trace it, I have categorized that as non-contact. Pointing and gesturing make up a huge portion of this pie chart. And part of that is because it is easier to point or trace than it is to pick up a surface or draw on the surface. But I also believe that part of that is because students are inexperienced with the surface. All right. One other thing I want to point out is contour map. Students only interacted with the contour map 5 times, and that was over 3 groups. Students were instructed to interact with the contour map in the activity, and if they had done each instructed or each prompted use of the contour map, there would actually be 6 contour map interactions. The groups only used the contour map to align the surface to the contour map, which I asked them to do, but did not use it in a further question where I asked them to draw on the contour map. Part of that, again, is because students don't have experience with contour maps, but I also believe that part of that is because I did not include very much information on this contour map. Anything that they can see on this contour map, they could have gotten just as easily from the surface or from the things I asked them to draw on the surface. So, why did students interact with the surface? So, I have several categories here. I'm just going to go over the most important ones. So, we have compare, where students were comparing force, gravitational potential energy, slope, height of various points on the surface. We have derivative, where students examined the slope, the rate of change, or the derivative of gravitational potential energy. I mentioned all 3 things because some students did not use those terms interchangeably and were often confused about whether slope and derivative were the same thing. There was function, where students looked at the functional behavior. How does a variable increase over distance? How does it decrease? What does the slope do over the course of the area? We have location, where students confirmed or pointed out the location of an object on the surface. We have prompt, where the action was explicitly prompted by the activity. And then we have variable, which is similar to functional behavior, but students were not looking at the variable as a function. It was more of the height represents the gravitational potential energy, rather than the gravitational potential energy increases over distance. So, a couple of trends on this. Students mostly used the contour or the surface to compare, examine the derivative, and examine the functional behavior. So why use the surface? One of the things that I mentioned before is that students have chosen to use this surface. As you can see on this pie chart, only 22 of the actions were prompted. The other 151 actions were chosen by the students. They were not told to do those things by either myself or the instructor or the activity. This shows that students decided the surface was the best way and easiest way to communicate their findings, their reasonings, and their difficulties with the other students in their group. Another thing, as I also mentioned before, is this helps them look at abstract and mathematical concepts like the derivative, the slope, the rate of change, and also looking at functional behavior and comparing abstract things on the surface. So, relating this to before when I talked about difficulties students have with potential energy, being able to visualize the tangent specifically, but also other things like functional behavior, variables, can help them overcome the disconnect between what they're being told in an equation and what they are imagining in their mind is a representation of this. Another way that you, another reason that you should use this surface is that it's applicable to other activities, and that is not just other activities about gravitational potential energy and force and the relationship between those, but anything where a function can be modeled with this surface. Future research can delve further into how, in what ways this surface can help remedy and better confront the difficulties that students have with potential energy. All right, thank you. Questions? Yeah.
What makes you choose to define tracing and drawing separately?
Oh, okay. Part of that was because when the students were drawing, that was almost entirely prompted by the activity. Here we go. So they drew 17 times. 15 of those were things that were explicitly told to them to do by the activity. The other 2 were drawings that were immediately erased. And so I wanted to point that out because a lot of times when students are introduced to something for the first time, and I guess you can see this with like small children as well, you give them something new and they don't want to break it, they don't want to do anything wrong with it, they don't want to get in trouble for like messing it up. And so a lot of times, and that goes along with the non-contact thing, right? Students don't want to mess with it. Yeah.
You mentioned that one of the minus signs was a difficulty that people had.
Yeah.
Did you find that anybody was able to use the surface in order to like model the minus sign, or like?
Oh, okay, yeah. So perhaps not model the minus sign, but there was an interaction with the group that was using the pen as a tangent. They had called the TA over to help them with a problem, and she was able to tell them, like, okay, hold out the surface, which direction is R? And they were like, okay, it's this way, because this is the Earth. And so then which direction is the force? And so they were holding this up, and they were like, oh, it's inward, it's this way. So perhaps not, you can't just do this and then see, oh yeah, that's positive or negative, but they were able to use the surface to demonstrate and reconcile the signs. Okay.